So now I talked about spaghetti code, right? Let's look at spaghetti code example using this flowchart, this traditional flowchart. You can definitely end up writing something like this because it allows arrows and the diamonds and symbols. All these symbols are allowed. No? So here you have the start, and then you go in to a diamond and you ask. Don't try to understand this. Okay, you don't need to read all this and understand it. Just to show how complicated you can write something using this flowchart. Okay, so now if you look at this, if this is yes, you go here, you do this, and then you come and end up here, right? If it is no, you do this, and then go down, check for another condition. If it is yes, you go here. If it is no, you go here. You do another condition. See, always diamond will have two exits, one for yes and one for no. And then you do this, and then you come back into this again. And just imagine something like this. You are writing a code, and your program is now working. After 6 months, somebody comes and says, I want some changes in this and certain things have to be done. You will have a tough time trying to figure out where to put that, where to edit, it's so complicated going here and there, and this is why it is known as spaghetti. So since these arrows are there and you can write something like this is possible, this traditional flowchart, you will always end up writing something like this, which is known as spaghetti code, and it will be very difficult to maintain in the future. Writing at the beginning and making it work, you might be able to do it because while you're writing, you understand each of these. No, but after 6 months, you have forgotten everything, and then you go back and look at this, you can't understand. So whole idea is write structured programs so you can understand them and maintain them and modify them in the future. So this is one example of a spaghetti code. You can always end up like this. Okay. Oh, you might be doing something like this. So your flowchart, when you write using this traditional symbols, these are the possibilities that can happen, which are known as a spaghetti code. So I don't want to get into this. I can start off with this, but then we will go into this, and then I have to spend a lot more time trying to take you all out of this and get into normal structured program. So this is the reason why I don't want to use the traditional flowchart and start your programming career. Okay, so let's look at NS chart. NS chart is having only few symbols. One is for process. This is the main symbol. This is where you put your start, your end, like what we saw in the other flowchart. Plus anything you want to do in the program, you can write inside this. Do this, do this, do this, do this, all that. So okay, so we will see examples. This is one symbol called process, and this is one of the this is the main symbol in this NS chart. Okay, this is the part that you will find most of the time. Always you will be working with this. This is our main area, main programming. All the instructions are given through this process. Okay, next one is decision. In the decision, you will be writing a condition. Okay, like this. We have already gone through conditions, single conditions, the relational operator using and or not, all that you know, right? And always a condition will evaluate to a true or false, yes or no, as you know. Okay, true or false. True means yes, false means no. So what this symbol or this particular thing called decision does is, if this condition is true, it will go through the yes path. If the condition is false, it will go through the no path. And what do we have here and here? These are processes. So you can write your processes here and another set of processes here. Both processes won't happen. If the condition is true, this process will happen and it will come out. If this condition is false, this process will happen. Both of them won't happen. If you want both of them to happen, then actually you don't need a condition. You can write a process for this and write another process below that for this one and make both happen without a condition. So only time you put a condition is if you want to decide, and okay, if it is this situation, I want to do this. If it is this situation, I don't want to do that, but I want to do something else. Whenever you have a situation like that, only you will be using a decision. Okay, just because decision is there, you don't have to use it. If your requirement is such that you want to decide on certain condition, and if it is yes, you want to do certain thing. If it's no, if you want to do certain thing, then you use this decision box. Okay, so this is our second symbol that we have. So first symbol is the process, second symbol is the condition, and in the condition the top part is the condition, here yes and here no, and these are again processes or other things, as we will see that you can write a lot of other things also here. Thirdly, we have a loop, something you want to repeat. If there is a requirement for you to repeat, now all these uh, things in this in the repetition is based on the condition. If the condition is true, only it will repeat. What does it repeat? It repeats whatever that is you have here. What do we have here? We have here these processes. We can also write other things, but mainly this is a process, same as this. Okay, its shape is slightly different because it is written to fit in this condition, this while loop. This is the while loop. Okay, so you check a condition. Is the condition true? You do this. After you do that, you again check the condition. Okay, the condition is true or false? True. Do again. Again, finish, and then again check the condition. So every time after the end, you check the condition to see whether the condition has now changed. If it is true, keep on doing. So until the condition becomes false, you will be repeating this over and over again. That is why it's called a loop. It continues to do something throughout. So we will see some examples in our later sessions, okay, and to understand. So as you enter, you check a condition. Condition is true, you do this. If the condition is false, without doing this, you come out to the next line here. The line following that, you come and do and continue from there. So if the condition is false, you will not be doing this. Okay, but in a decision, if the condition is true, you will be doing this. If the condition is false, you will be doing this, but only once. It will not repeat after that. It will just come out. But when we put it in a loop, it will, as long as the condition is true, it will do this. Again, check the condition after finishing all this. It will check the condition again. True, do this. Again, go and check the condition. Only time it will come out is when the condition becomes false. So if the condition never becomes false, then this will become an unending loop, never-ending loop. It will just continue, continue, continue. This is why computers sometimes hang up. They go into a loop and you keep on doing the same thing. The condition is not changing, so it's repeating, 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 and the computer gets stuck. So that is one of the ways computer getting stuck can happen, through these loops. Okay. So this is one type of loop. We have one more type of loop called loop until. In this, the difference between these two is, here what we do is, as you get into this, you do the process first and then you check the condition. If the condition is true, do the process again and then check the condition. So the difference between these two is, this is check the condition first and then do the process, then check the condition again, do the process, check the condition again, keep on doing that until the condition becomes false and come out. So this one, it will first do the process without any checking of condition. After finishing the process, it will check the condition. If the condition is true, once more it will do the process. Condition is true, so it will keep on doing this until, that's why this loop is called until this condition becomes false. The moment this is false, it will come out down, it will not repeat. So the repetition stops the moment this condition is false. So the difference between the first one and second one is, first one, the condition is checked right at the beginning, and then if it is true only, it goes into the process. In the second one, it goes into the process anyhow, and then after the process is done at least once, only the condition is checked. So if you put it like this, if the condition is wrong the first time, the process will never happen. In this way, process will definitely happen once, because the condition is checked only after doing the process first time. So if your requirement is to do something first and then check the condition, you can use this. If your requirement is check the condition and do the loop, you use this. So either way, this, both of them, we can call it a loop. So basically we have only these three symbols. One is process, one is decision, the other is loop. Two different types of loops. Okay, so let's see an example of a flowchart written. Now we already saw a traditional flowchart example. Okay, so let's see a NS flowchart example. You might put something like that. That's a process. Okay, and the first, like in the other traditional flowchart, first process you have to indicate, okay, this is the starting point. So you have to say start. Okay, always you should start with the start. Okay, then you can have another process happening. and another process, or you can have another condition happening, a decision. So here we have a start, we have another process happening here, and then we are doing a condition. Uh, then let's say another process happening, that is this one process, and we are going to use a loop while condition. Okay, and then again another process, and maybe another process to end. So this is how you will be writing a flowchart, but you won't leave these spaces. So I just wrote it, show these are separate things. See, this is a process, this is a process, this is a process, this is a process, this is a process. Okay, this is a condition, and this is a condition. But when you're writing, you have to put them like that. After the first process, write the next process, then you write the condition. If there is a condition to be written, whether this needs to come in or not, it depends on your requirement. Okay, then after that the other process is written after that, then the next condition is written below that, and then the next process is written there, and end. So the traditional flow chart won't look like this. We already saw that. NS chart flowchart will look something like this. This is an example. Okay, all your flowcharts need not look exactly same. This is just an example to show. So here what happens, start, then some process happens, then a condition happens. If the condition is true, you do this process, and then come here, do this process, and then go into this condition. And then if the condition is true, do this process, and then check the condition again, true, do it, and then check the condition again, true, do it, check, do, check, do, until the condition is false. The moment condition false, comes to the next line, do this process, and then end and stop. That's all. Whereas if you start, do the process, and check the condition, if the condition is false, then you go through this side. So when the condition was true, we went through this and continued like that. When the condition is false, you go through this, do this part, and go down. Okay. So here you are given choice. If the condition is true, do something. If the condition is false, do something else. So you can define them. Both of them won't happen. If it is true only, this will happen. If this is false, this will happen. So this is how the traditional, NS chart, flow chart will look like. Okay. So now, most important thing, since there are no arrows, see, no arrow symbols, only process, decision, and loop. In the traditional flowchart, we had the arrows also. Okay, since there are no arrows in NS chart, you cannot jump to any point like you could in traditional. Now we saw the spaghetti code, right? We just put lines wherever we feel like. From here, go there, go there, go there. Now that sort of a thing you can't do here. So you have by design of this NS chart symbols, you are restricted to work within this, think within this. All your solutions you have to think within this area, in the sense of process or decision or loop, and you bring it. Okay, so this is an example, and so most important thing is there are no arrows, so you can't put an arrow from here and say, okay, jump here. No way. If you want to jump to some place, it has to come through a condition. So in a condition only, something will repeat. So now here you are keeping on repeating whatever that is here. Okay, so that's an example of how the NS chart looks like.